Thank you very much. And I also like to thank the organizers for kindly accepting my paper for presentation at this workshop. And in particular, I like to thank Duopoly. As you can see, the title of the paper, Free Licensing in a Differentiated Duopoly. And myself is Tarun Kabiraj, and my co-authors are Rittwik, Chatterjee and Srobonti Chattopadhyay. Now, we all know that technology licensing is a very common phenomenon in industries. A firm which holds a superior technology, often it transfers its knowledge to other firms which have backward technologies so as to make the profits. And when technology transfer takes place, the license's cost of production falls, or it improves the quality of the product. Now, if the transferor is a non-producing firm, that is outsider, or it does not compete in the transferee's market, transfer is always feasible to the extent that it enhances the transferee's profit. In such a situation, transferor's problem is to design a contract to extract a maximum possible surplus. If the licensor and the licensee compete in the same marketplace, when it is insider, then technology licensing reduces the operational profit of the licensor. Therefore, it is necessary that it will overcompensate the loss, and it designs the contract like fixed fee contract or royalty contract or two-part tariff and so on. There is in fact a vast literature discussing the optimal licensing contracts. In fact, even among the presenters today and tomorrow, and also among the participants, there are many who have contributed to this literature. Now, the important factors that determine the optimal licensing contracts are particularly whether the innovator is insider or outsider, that is producing or non-producing firm. It depends on the market structure like monopoly, duopoly, oligopoly, or vertical structure or holding structure. It also depends on the competition, whether price competition or quantity competition. Nature of good, like whether it is homogeneous goods or differentiated products. It also depends on the size of the innovation, like small, medium, and large. Also, information is an important factor, whether information is symmetric or asymmetric, and also effectiveness of the patent protection and its enforcement is another important factor, and so on. There is also a literature that shows that sometimes technology licensing results in an upward shift of the market demand. This further counters the negative effect of technology transfer on the transferor's profit. For example, Shepard, 1987, Stamatopoulos, 2006, Stamatopoulos and Tauman, 2008, and so on. Now, basically, their view is that licensing enhances quality and hence a shift of the market demand. Whether licensing will occur or not depends on various factors like consumers' preference, consumers' heterogeneity, consumers' differential perception about quality, and so in general it is willingness to pay. It also depends on whether the market is fully covered or not, also the size of the innovation, and so on. So in this paper, our main question is, can free licensing be profitable? Free licensing be profitable? That is, whether licensing can be transferred without any, against no payments. Now, when we raise this question is not without any context. For instance, the music industry often benefits by allowing free downloading to music consumers. For example, Pirjan and Olbrock have shown that when consumers taste heterogeneity and product diversity are sufficiently large, then it can be profitable. Also, pre-licensing of innovations in the computer software industry is also common. However, in this paper, we raise this issue, but without questioning whether pre-licensing is optimal or not. So basically our question is that whether pre-licensing can be profitable or not. It is not that whether pre-licensing is optimal or not. Of course.
Excuse me, here the licensing is being done by an insider necessarily, because if it's
I'm coming because it's a duopoly structure, and one fund of them will transfer to the other. I'm coming to the structure immediately. Very soon.
Let me just ask a quick question.
Yes.
What do you mean by licensing? There is a contract?
Licensing here, licensing basically we mean it is a technology transfer. So superior firm, the firm which holds superior technology, it transfers its production knowledge to the other. And general licensing may be for the finite period, or maybe for infinite period. So licensing is against you are allowing the other firm to use your knowledge. That's licensing. Now there can be situations. In fact, as I say that whether pre-licensing we are talking about, but there can be situations when royalty licensing is not possible, at least theoretically, because due to weak patent protection or enforcement, you cannot write the royalty contract. Or even when you can write the pre-licensing, but pre-licensing may not be profitable. For example, in a Kundo duopoly, if unit cost of production is low, or the product goods are very close substitutes, then pre-licensing is not profitable. So there are many papers like Marjit 1990, Wang 1998, 2002, and so on. So what we shall do in this paper? Basically, we are constructing a differentiated duopoly model with quantity competition. Initially, one firm holds the superior production knowledge, and if it is transferred to the other firm, it saves the resources of the transferee, and hence it reduces the cost of production. Further, as we see, it will be optimal for the licensee to buy the inputs from the licensor, although licensee can produce the inputs by itself. Now, by sharing its production knowledge, the licensor creates competition from the licensee. Now, this loss of profit due to competition may be outweighed by the revenue it earns from the sale of inputs to the competitor. So basically, we are taking this tool that the loss of profit, you can compensate it by means of selling inputs to the competitor. Hence, it is possible that pre-licensing of superior technology may be mutually beneficial. Now, the existing literature on pre-licensing, not many, but it mostly focuses on network externalities or the shift of the market demand for the product. For instance, Conrad, 1995, analyzes the benefits of market expansion from licensing and derives conditions for which it is profitable for an incumbent to license its technology for free to an entrant who competes in the incumbent's market. The paper suggests that innovators' best strategy may be to encourage clones of the products when a network externality is present. Then Boivin and Langenier, 2005, they assume that structure of the market will influence the market demand. In particular, the consumer's willingness to pay for a product is larger when it is duopoly than when it is monopoly. Hence, licensing results in an upward shift of the market demand function. And it is possible that when the shift is sufficiently large, then licensing can be profitable. Also, free revealing knowledge of the newly innovative products or services is studied in von Hippel and von Krogh 2006 paper. But in contrary, in our paper, there is no network externalities, no market demand shift effect. And also those papers I have mentioned, they have initially pre-license situation is a monopoly, but in our case, we are considering it's a duopoly. Now, before going to the model, let us just mention the results of the paper. We show that under unconstrained input pricing, pre-licensing will be always profitable, but under constrained input pricing, pre-licensing of technology can be profitable under some conditions. We show that pre-licensing will never be profitable in our structure if products are homogeneous. And when products are less than perfect substitutes, pre-licensing of technology can be profitable only if the innovation size is small and the licensor sells inputs at a sufficiently high price. If the input production cost increases or the degree of product substitution rises, pre-licensing is more difficult to occur. On the other hand, interestingly, an increase in market size also reduces the possibility of pre-licensing. Finally, we derive an implication in a very heuristic manner, the implication of the pre-licensing in the context of pollution problem in the production process. We show
Can you give some intuition why the licensee must buy inputs from the licensor?
Immediately I am coming to that. Why?
Getting the knowledge, why does he need to buy inputs from?
Yeah, although it can, although licensing itself can produce, but why it is buying inputs from the licensor, I am coming to that.
Okay. This is the new aspect of your model. It was not there in the previous models you described, right?
Yes.
Okay. The digital printers are given for free, but you have to pay for the ink.
Yeah, so I am taking another. So instead of network externalities, instead of demand shift effect, I am taking the route or channel of selling inputs. So we are thinking the situations where input selling will be optimal, or for the licensee it is also optimal to buy inputs from the licensor.
So the licensor is producing other things which are required and which it has a monopoly on.
Yes. In fact, initially when we started in different structure, we don't need to be the monopoly, but in our case, because we are talking about duopoly, that's why better to restrict to that.
So it is in a sense licensing of the input for upfront fee, in a sense.
No, licensing
per unit royalty.
No, I am talking about licensing of the production knowledge, final goods production knowledge. Whereas,
okay, fine. You don't license it. You give for free the production, then the knowledge.
Yes. So when you're transferring the knowledge, yes, I am selling the inputs. Okay. Fine. Now, since we are considering the differentiated duopoly model, in the literature there are already many differentiated duopoly models like this as mentioned here. But our paper differs from those in various respects. For example, those papers considers technology licensing under fee or royalty payments. But as I say, that in our paper, we are considering licensing occurs for free. In our paper, the two sources of revenue of the licensor are, one is from market operation, profit from market operation, and another from selling inputs to the licensor. Even after technology transfer, cost asymmetry prevails, although the gap is reduced. There are some papers where also in the post-licensing situation, technological asymmetry prevails. For example, Sina 2016, Wang, Liang, and Zhou 2013 economic modeling paper. They have also this type, but they don't have the question of pre-licensing. Generally, a larger market size increases the possibility of licensing, but as I have said earlier, in our case, it reduces the possibility of pre-licensing.
So just a clarification.
Yes.
The licensor has a choice of charging or not, or charging zero, or charging epsilon, or charging a million.
Yeah, it will optimally decide the input price.
Optimality decides that he will charge zero.
It will optimally decide the input price.
Okay. Okay.
Okay.
So he is allowed to charge, but he chooses not to charge.
Of course, it can. If it is optimal, then it will not charge.
Okay.
Okay. Now there are again some papers like Mukherjee 2019, Mukherjee Broland 2019. Those papers do not discuss free licensing, but they can be implicated.
What do you mean?
In particular, implicated in the sense that, for example, look that when they consider the entry in the incumbents market. Now, as entry occurs in the market, then it has its effect in the input market. The competition in the input market goes up. As a result, input price falls, and that benefits the incumbent. So, implication in the sense that entry means as if we can think of as if we are licensing, they are getting the license. So, in that sense, it is implicated. Now, in our paper, after licensing, in their paper, but although their paper input price falls, but in our paper, input price charged in the compared to pre-licensing situation, in the post-licensing situation, input price will not fall. It may increase also. So let us come to the structure of the model. As I have said, it's a differentiated duopoly with quantity competition. Market demand function is the linear standard, A minus QI minus BQJ for the ith firm. And such a demand function, as you know, that can be derived from quadratic utility function. A, common intercept, here represents the market size. And B, coefficient of QJ, B represents the degree of product substitution. B equal to 0 means products are independent, and B equal to 1 means products are perfectly homogeneous. Now, technology, as we are defining in this paper, technology means the input requirements per unit of output. That is how much input is required to produce 1 unit of output. That defines what technology. Initially, we are assuming that there is a technological asymmetry. That is, firm 1 possesses a superior technology, possibly due to some prior innovation. But both the products require one common input, and no other inputs are required. But as you can understand, that this is a simplicity assumption. We can assume a vector of common inputs, or we can include some other inputs, but this can be modeled. Now, given this technological definition, so what is the firm 2's technology? Firm 2's technology is such that it produces one output using one input. So one input produces one output. And also it can produce input for itself at the cost R per unit, at the cost per R per unit. Therefore, R assuming less than A. But firm 1's technology, on the other hand, because it is a superior technology, we are assuming that it requires M units input for 1 unit output, and M is less than 1. So that says that firm 1's technology is superior. Also, firm 1 has the cost advantage to produce input. Cost is C. C is less than R. Therefore, initially, this is the A1 that gives the initial assumptions. A greater than R, greater than C positive, B lying between 0 and 1, M lying between 0 and 1. Now, given the cost advantage, the question that you are raising, why it can sell inputs or why the license will buy from that. Given the cost advantage of producing inputs, you see that firm 1 can charge a price, say W. So long as W is greater than C and less than or equal to R, it is optimal for firm 2 to buy inputs from firm 1, that is from the licensor. If we consider the constant input price is W bar, if we assume that constant input price is W bar, constant input price in the sense that suppose that R is ignored, or suppose that firm 2 cannot produce inputs, then what the price it would charge? That is called W bar. Now, if W bar is greater than or equal to R, in that case, input price will be R. We call this in the case as the constrained input pricing. On the other hand, if W bar is less than R, then firm 1 will charge the price W bar, and we call this situation unconstrained optimal input price. So that explains why that the input price is charged optimally. Since you're talking about technology transfer, therefore you're assuming that Farm 1's production technology is transferable. So at the beginning, Farm 1 will decide whether it will license its superior technology to Farm 2 or not. Now, given this specification of the technology, then what will be the production cost? If it is the no licensing, then Farm 1's marginal cost is MC, marginal cost of producing final goods, because it produces input at cost C and it requires M units of inputs, so MC. And Farm 2 buys inputs from Farm 1 at price W. Therefore, it requires one input to produce one input output. Therefore, Farm 2's input production cost is W. Under licensing, yes.
I have a quick question. So you are assuming that the superior farm is superior in two respects. One is using less inputs, as well as the cost of production is less.
Correct.
Do you need both the instruments, or if you can use just one of the instruments?
No, I need both, because first of all, I'm considering transfer, and second, I need to get some advantage. So we need that I can sell the inputs. Therefore, how I can sell the inputs? So I should have some advantage in input production. As I am talking about earlier, that I was earlier thinking in some different way, the structure, where R can be thought of as coming from some other market structure, but that is not consistent yet, so I am avoiding that. So under free licensing, Farm 1's marginal cost of production is MC, M is input requirement, and C is cost, but Farm 2's marginal cost is MW. It buys inputs at price W, but it now requires, under the transfer case, it requires M units, M inputs. Therefore, MW is the production cost.
Can I ask you?
Sure.
So there is another strategy of Farm 1, which you can call outsourcing, which is, Farm 2 places the input orders and there is no transfer of technology, but Farm 1 just makes the input and gives it to Farm 2. Do you?
Here, because you see that I am considering transfer of technology means transfer of the final goods technology, final goods production, not input production. I am selling inputs, but I am transferring the technology of the final good production. Okay. Now, so this is the game tree. Farm 1 decides whether pre-licensing or not, and input price is decided before the quantity competition. Now, given the model, suppose W bar N and W bar F are the unconstant input prices under no licensing and free licensing. So these are suppose that the optimal input prices under unconstant input prices under no licensing and free licensing. Then unconstant input price will occur if R is greater than max of W bar N and W bar F. So we are considering that unconstant input pricing in both under both licensing and no license situation. And constant input pricing will occur if R is less than or equal to mean of W bar N and W bar F. There is a third possibility, of course, that where R belongs to this interval. I can give you the intuition, but I have not. It is not fully worked out yet. But the result, I can give some intuition about that. So let's first consider the case of unconstant input pricing. That is, R is greater.
Clarification. So
Yes.
you just examine two cases. One is no licensing. The other one is free licensing.
Yes.
What about in between?
In between?
Yeah, I mean, not free licensing.
You
but
said
licensing.
So no licensing is basically the default. That if I don't license, then it's basically it becomes the simple duopoly structure where asymmetric technology prevails.
no, I thought.
Can I
you
sell
said-
the, sorry, can I sell the inputs even if I don't transfer the technology? Is that possible?
Yes, of course.
I thought you said earlier that suppose you look at a bigger game where the licensor can charge any fee from 0 to infinity. And then in that game, he will charge 0 at Nash.
Here fee means
but he chooses to charge 0. That's, I thought, what you said.
No. Here fee means basically here the input price I'm talking about, not fee for the technology. It is the price of the input. I'm talking about price of the input. Now,
but maybe he could do better by charging a fee instead of giving it free.
So I have already talked about that. I am not talking about the optimal contract.
Of course, you said optimal. Sorry. Okay.
I am not talking about optimal contract, but in the context of input cell, I am considering that optimal input price. Of course, in reality, it may be possible that when free licensing is possible, and if it is possible to charge some fee or royalty, possibly I will charge. But I have already mentioned that there can be situations where you cannot charge royalty because of enforcement problem or fee, it may not be profitable. Okay. So come to the case of unconstant input pricing. So in this case, as you know that R is greater than, so this is the case, R is greater than max of that. Now under no licensing and free licensing, these are the prices, W/F and W/N under free licensing and no licensing. And we can show easily that W/F is greater than W/N. This means that licensor can charge a higher input price to extract more surplus due to transfer technology. So after transfer, in fact, you can charge a higher price as well. Of course, here R is not playing any role. And the result that you can, by comparing the payoffs, you can get the result. Under constant input pricing, free licensing is always profitable. That's why, to me, it appears that this is not a very interesting case, and R is also not playing role, and free licensing is always profitable. So we are basically in the paper focusing on constrained input pricing. So under constrained input pricing, both under no licensing and the optimal input price will be R, as we have already mentioned. Now, if it is no licensing equilibrium, then we have already mentioned the unit costs of production will be MC and R for farm 1 and farm 2. Then profit functions are this. For pi 1, the first part is the profit from market operation. It has its margin, it has its cost, unit cost is MC. And second part is the revenue from input cell. Farm 2, buying inputs at the price R and produces Q2, and given its technology, Q2 units of inputs are demanded. Therefore, R minus C Q2 is the revenue from input cell. Then you can solve Puno game. We can solve outputs. Equilibrium outputs are Q1N and Q2N. Now, since we are talking about that initially market structure is duopoly, therefore we must require to assume that Q2N is positive, which means that R has to be less than a critical level called R bar. Where R bar depends on the parameters like A, B, C, M, everything, okay, except R. Then you can, under these conditions, you can find out also the profit. Yes, sure.
But what you are calling, the way it looks, this is essentially like a, I know it's a different situation, but it's essentially a licensing problem where the, farm 1 is charging a royalty effectively. Isn't it the same thing?
In some sense, possibly. But markets then your formula, profit functions formula will be different, right? Profit expressions will be different. So given this, our profit functions for farm 1 under no licensing is this one. So second part is the revenue. First part is the operational profit from market operation, and farm 2's profit is this one. Now come to free licensing case. Then cost of the production is MC and AMR, as I have already mentioned. Then difference between the difference of this case to earlier case is here, that now farm 2 produces output with the cost MR. It produces Q2, but its input demand is now MQ2. Therefore, farm wants revenue is now R minus C into MQ2. Again, you can solve the Kurno game. You can find out quantities and profits. So these are the expressions of quantities and profits. Immediately comparing licensing, free licensing and no licensing, you can get Q1F less than Q1N, Q2F greater than Q2N, Pi2F greater than Pi2N. It is simple reason that when transfer takes place, competition increases. As a result, licensors output falls, licensee's output goes up, and also its profit goes up. But what will be its profit? Obviously, when licensing will occur, then Pi1F will have to be greater than Pi1N. But if we simply compare without any restrictions, then operational profit must fall because Q1F is less than Q1N. Therefore, operational profit must fall. But at the same time, its volume of input sale is ambiguous. Whether you will sell more inputs or less inputs, you don't know, because Q2N is the no licensing input sale. Under licensing, you're selling inputs MQ2F. Although Q2F is greater than Q2N, but M is less than 1. Even when input sale goes up, increased revenue from input sale may not be large enough to overcompensate the loss of operational profit. So we need to define the conditions for free licensing. Given A1 is the usual assumptions, and we need to assume A2 for the initial duopoly, and so that it is profitable, free licensing, we need to assume that Pi1F is greater than Pi1N. Now you see that R is playing important role here, and so we are focusing on the two parameters M and R. M represents the technology, R is the constraint that the licensor is facing. The other parameters in the model A, B, C, therefore we can also study the effect of the change of A, B, C on M and R, and therefore on the decisions of licensing or no licensing. Immediately you can get the result that free licensing is never profitable if the products are perfect substitute to each other. That is when B equal to 1. The intuition is very simple. If the products are homogeneous, so there will be fierce competition in the product market that will reduce hard one's operational profit substantially, making the overall profit to fall. In the other extreme case, if the products are independent, that is B equal to 0, then free licensing is profitable if and only if this condition holds. In particular, to focus on M, that M has to be larger than its critical level. Look, that since B equal to 0 independent, therefore products are independent, so there is no competition in the product market. Hence, Harmon's output and operational profit remains unchanged. But total input sale to Farm 2 may or may not go up. If technology is very superior, that is M is small enough, then effectively input sale to Farm 2 will fall. Hence, revenue from input sale may also fall. Therefore, we require that M has to be greater than a critical level. Just a second. So to define the now conditions for free licensing, therefore we need, given A, we need to satisfy A2 and 1. 1 means profitability questions. Now if we taking the equality sign for condition A2, we can find a locus of MR in the plane R and M. And as you can see the expression, it is a linear apostrophe curve. And its boundary, that is for any M, there is a maximum R bar. Therefore, the condition will be satisfied if R is less than R bar. Therefore, all points below this curve will satisfy the assumption 2. Second conditions, the condition 1, you can also consider a locus, but directly deriving the locus is not simple. So we have used two lemmas, and by these two lemmas we have characterized the profit this expression, and ultimately we have shown that this expression is a downward sloping, and it intersects the other locus corresponding to at M star. So there is an M star where these two curves intersect to each other. And if R is, so it's upper boundary is denote this lower R. Therefore, if R is R is greater than lower R bar, then this condition will be satisfied. Probability condition will be satisfied. Therefore, both the conditions will be satisfied when M is greater than M star. So technology has to be backward, relatively backward, and R will have to be in this interval. So it will not be very high or very low. It has to be in an interval. This gives you the main result that given as option A1, A2, we have for all M belonging to M star and 1, we can have an interval R, from lower R bar to upper R bar, where lower R bar is greater than C, such that this profitability condition is satisfied. Further, the difference between R bar and lower R bar with respect to M is increasing in M. Pay attention, under licensing, firm one's operational profit always falls. Now, if M is very small, that is technology is much superior, then under licensing, loss of firm one's operational profit will be to the extent that it cannot be outweighed by the gain from the input cell, if any. On the other hand, if R is not sufficiently high, increase in revenue from input cell will not be large enough. And as technology superiority falls, the gap between lower R bar and upper R bar increases. This means the possibility of free licensing also increases when M becomes larger. That gives you an example. I have taken A equal to 1, B equal to 0.5, C equal to 0.4. That solves the critical level M star equal to 0.4745. Now, as M goes up, you can see that lower R bar is increasing, lower R bar is falling, and upper bar is increasing, so the gap is increasing. Let us come to now the comparative statistical results, because I have already noted that A, B, C are parameters. Now, when you are discussing the comparative static results, then assume that given the parameter vectors A, B, C, M, R, initially the parameter vector is such that M and R belong to the relevant interval, so that initially technology transfer is free, technology transfer is possible. Now, with respect to A, B, C, if we take the comparative static results on M star, then del M star del A fall. M star will fall as A goes up. As B and C go up, M star increases. First consider that A goes up. A means market size. So when A goes up, we have shown that both upper R bar and lower R bar is higher, which means that both the locus shifts up. But del M star del A is negative, which means cut of M star falls. Therefore, so far as the interval of M is concerned, interval is going up. So feasible interval for free licensing goes up, but at the same time lower R bar goes up as a consequence of an increase in A. Therefore, the initial MR may or may not be within the new feasible free licensing zone. That is shown in the diagram. And we have shown that if increase in A is small, free licensing will continue to be profitable. But if it is large, in the new parametric situation, free licensing may not be profitable. So think of, suppose that initially, given the parameters, your M star is this one, and this point, that is M0 and R0, is the initial point, initial parameter. And this initial parameter lying between this boundary, this interval, which means that free licensing is possible initially. Now suppose that market size goes up by small amount, that results the shift of the both the curves upward, and that gives you the intersection m star 1. But the shift is such that the interval and the new interval, this new interval contains the initial MR, M naught R naught. Therefore, when market size is a small, increase of market size is small, again, it continues that free licensing is possible. But suppose that A goes up by the larger amount. As a result, critical M star is M star 2. The new interval becomes now this one, and this interval does not contain the initial M naught R naught, which means that if A is large enough, then your free licensing will not occur. Therefore, if A is small, free licensing will continue to be profitable. But if it is large, in the new parametric situation, free licensing may not be profitable.
Tarun, I just want to remind you, you have like 4 minutes.
Oh, I see. Okay. Now, this gives you an example. Given this parameter, where A is 1.0, now as A goes up to 1.1, we have shown that free licensing continues to be profitable. If A equal to 1.255, free licensing fails to be satisfied. Now, when B and C goes up, M star goes up, which means that immediately your one interval falls. Therefore, technical licensing or free licensing falls. So summary of this result gives you proposition 5. The possibility of free licensing goes down when either the degree of product differentiation falls, or the input cost of farm 1 increases. On the other hand, an increase in market size may reduce the possibility of free licensing. Finally, just to get an implication, as I say, it is heuristic, very heuristic manner to see the implication in the context of pollution problem. Let us suppose that S0 and S1 be the pollution per unit of output generated by using backward and superior technologies. Now, as you know, that production by backward technologies damage the atmosphere, air space, and water body by means of emitting carbon, gaseous pollutants, and other obnoxious chemicals and particles. Therefore, the usual assumption must be that S0 is greater than S1 and positive. Now, in our duopoly structure, under no licensing and free licensing, the pollution generated will be Ln and Lf. Then, free licensing will reduce overall pollution if and only if Lf is less than Ln. The sufficient condition for this is S0 by S1 greater than Q2F by Q2N. Note that Q2F is greater than Q2N and S0 is greater than S1. Therefore, for total free license will reduce pollution, provided that new technology reduces pollution to a larger extent. So S1 has to be very small enough. Welfare implications for our results, that under free licensing, each firm's profit goes up, therefore industry profit goes up. Also, industry output increases under free licensing. This means consumer surplus also increases unambiguously. Further, if that condition 2 holds, that is pollution restriction satisfies, then overall environment becomes less polluted. This further increases welfare. Hence, under this situation, the overall welfare under free licensing must increase unambiguously. Just quickly to summarize the results, we have studied the possibility of free licensing with no network externalities, no demand shift effect. We have constructed a stylistic differentiated duopoly model with quantity competition. Superior technology reduces input requirements and the efficient firm produces inputs at a lower cost. Hence, the inefficient firm buys inputs from the efficient firm. The possibility of free licensing arises because under licensing, the licensor's loss of profit due to competition can be outweighed under some conditions by the revenue it earns from the sale of inputs. Under constant input pricing, free licensing is always profitable. Under the assumption of constant input pricing, free licensing can occur under some conditions, that is, innovation must not be too small. Input price has to be sufficiently large. Further, as technology superiority falls, the possibility of free licensing increases. If the input production cost or degree of product substitution goes up, possibility of free licensing decreases. More importantly, an increase in market size also reduces the possibility of free licensing. If products are homogeneous, free licensing will never be profitable. Cost asymmetry prevails in the post-licensing situations. And finally, we have shown that this model can be used to show that pollution to output in the production process can be reduced under free licensing.
Right.
Thank you very much.
Yep. Thank you, Tarun. Any more questions or comments from the audience?
One question is that if the speaker agrees, we have a 15-minute break. If the speaker agrees to stay on, we can ask him questions even during the break while others are taking a break.
Sure, sure.
Sure.
Okay. So I will wait till the break starts. Then I have quite a lot of questions to ask, just for clarification.
Yes.
Sure. Yeah.
Yeah, in fact, it is a working in progress. Therefore, your comments and questions will be very helpful to us.
It will at least be helpful to me.
So now it's officially the time for the break. So you can go ahead and ask.
Okay. So my first question is, can you show us the game tree which you had?
Yes.
This is related to Yair's question also, I think. Anyway, you have free licensing and no license.
Yeah.
Let us introduce licensing with all possible fees. So I want to fill the gap and have a continuum of moves of firm 1. Free licensing means it's going to charge 0. No licensing means it's going to charge infinity. And in between, you have all the numbers. Let's imagine that. Okay, infinity means some 1 trillion.
Yeah.
Infinity.
Of course.
Now look at that.
So this price means fee means fixed fee you're talking about, or what?
No. I'm just looking at the same game, but I'm now imagining a continuum of moves in the first step of firm 1.
Okay.
Free licensing is going to charge 0. No licensing means it will charge $1 billion. And there are all the numbers in between 0 to 1 billion, a continuum of moves, and you play the game. Now I can easily, maybe your model can also bring to light some sufficient conditions where it will choose, the unique equilibrium will involve, it will choose to charge 0, even though it could charge more, because it values the sale of its input so much. Through your model, we can see extra special conditions where free licensing is better than any possible licensing, not just compared to no license.
Okay.
Is my question clear or not clear?
Yeah. So you are talking about that free licensing might be the optimal strategy of the firm.
Yeah.
Under some conditions.
Even though it could charge, it doesn't want to, because it cares about the sale of input so much more.
Okay, but you see that
your model could reveal sufficient conditions for that to be the case.
But in our model, you see that the restriction is that you cannot charge for the input. You cannot charge a very high price. Your restriction is that because the licensee can produce the inputs by itself at price R.
Yes. So there will be some sufficient conditions under which what I'm saying may be true. Where this guy can sell, I don't know the answer. It's just a question.
Yeah.
I don't know. I have to think.
Just to clarify, Tarun, I think what Pradeep is suggesting, that at least you consider 1 or 2 licensing mechanisms in between, where you are also, instead of between these extreme cases, you're also looking at a case where there is some possibility of some kind of licensing, and see whether you can get non-trivial results. I think that's what probably Pradeep is.
Yeah, but look, in this structure, you see that the way I have model, you see that that given that when you can charge some of the free licensing with this the result that have worked out, but even in this case, you can because the licensee enjoys some positive profit. So in this case, charging some fee or royalty or combination is always possible, so that the licensor can be better off.
I see.
Yeah,
so free licensing will not be dominated.
Yeah,
in this case, free licensing will not be dominated.
Can
will be dominated.
Is it always true, or you can look into the parametric conditions? What
No.
Pradeep is suggesting
No,
is at least
no, no.
one parametric condition where free licensing is better than others.
No, because I'm saying that when free licensing occurs, fund to the licensee has a positive profit.
Whether that's
So-
in your linear model, but I'm ready to think broadly of non-linearities in the demand, in the production. And then ask.
Okay.
Within a linear model, you may not get it.
Yes,
But
possibly.
why not get a more broad?
Yeah.
Oh, sure, I understand. Well, in fact,
So for
we are
example,
thinking.
suppose you have decreasing returns to scale in the cost, then it might be better that both of them produce.
True.
And you might get what Pradeep is suggesting.
Yes,
Yeah.
possibly. Yeah, in fact, we have tried to make the because when we include differential product, already the model little bit algebra becomes messy. But just to make the model as simple as possible, we have done this. But you are absolutely right. In fact, we are also thinking that when or under what conditions free licensing may appear to be the optimal policy. We are always thinking that.
The big constraint will always be you want a game with unique Nash equilibrium. That always bothers me because I like to.
That's right.
I keep thinking that there are many Nash and what happens depends on which one you look at. But if you have unique Nash,
Absolutely, you are absolutely right.
In this day of supercomputers, you can even just compute them.
No, that's right. You're absolutely right. Yeah, in fact, the value of the model will go up if free licensing appears as the best optimal policy.
Can I ask you a question?
Sure.
It seems to me that if we just consider the way you are doing it, not looking at the optimal contract, but free licensing is the profitable contract. It seems to me that to prove that free licensing is optimal, perhaps you don't need all these input selling things. And especially it is because of the type of demand condition you are considering. Let me give a quick example. Suppose if you think about your B is equal to 0. So the products are isolated. Okay, suppose I am the licensor, you are the licensee, and the products are isolated. So now I can always give you my technology, which will increase the total industry profit. So I am not, yeah.
Sure,
So I don't now if you work around that B close to 0, neighborhood of 0, you will still get a range of B in the neighborhood of 0, where free licensing will be optimal. I will not say optimal, will be profitable. Even if there is no input selling. Now what the input selling is doing is increasing that range. So what I'm saying that if you make this distinction clear, that when this input selling is important and when it is not.
So you can remember that when I initially talked about that, when I was just discussing the literature at the very beginning, you can see that I'm talking about that generally in the duopoly structure. When you're talking about the licensor, it decides its optimal policy, and in the duopoly structure, forget about the input cell. You can always construct the optimal contract, and as I said that it depends on your some. I've already mentioned that what will be the optimal contract fee or royalty, different factors that I mentioned already. So that is always possible without any consideration of input cell. But here, as I'm talking about, that whether, so you are talking about licensing with a fee, with charging some price, charging.
No, I'm not charging any fee. I'm not asking any fee. It's a free license.
So,
free license. So what I'm saying is this. Suppose your demand function, that B term is 0. That means the products are isolated.
Yes.
And I have a better technology than you.
Yes.
I just give you my technology free. No input cell, no price, nothing.
Right.
So it is not affecting my profit. It will increase your profit. So the total profit will increase.
Right.
Okay. So now, if you now consider not B exactly equal to 0, but neighborhood of 0, you will, due to continuity, will still get a range of B where I can just give my technology to you and the industry profit will increase. So without any fee, without any input cell, we can prove that just giving my technology to you is profitable compared to no licensing for in the neighborhood of B equal to 0.
But when I am transferring my technology without it, my profit will fall.
No,
Due to
no, that's
competition.
what I'm saying. No, that's what I'm saying.
Oh, independent products you're talking
Exactly.
about.
So that's for the intuition, you start from independent product. So my profit will be intact. I am increasing your profit. Now, if I make B very close to 0, this result will still hold because of continuity.
Look, my profit, which was unaffected at B equals 0, will be affected. Even by epsilon goes down, I won't do it.
It will.
No.
Look,
if B equal to 0, if B equal to 0, licensor's profit will not be affected at all.
Right.
But with B positive, even
it immediately it is fall.
Yes. When B positive, it will affect. But because of the continuity, you can prove that.
Yeah, but then
no.
Down, his profit will be affected negatively.
Must be affected.
Yeah.
Look the proportion 3.
You're not getting my point. I am saying that just for argument's sake, suppose B equal to 0.
Okay.
Where my profit is unaffected, your profit will increase.
Right.
Okay.
Now let B
now if B is positive but very close to 0,
but
yes,
positive.
my profit will fall. My profit will fall. Your profit will increase, but that increment will be more.
Yes. So what?
But I have to charge. So I have to take something.
Nash, I don't care about your profit.
No.
I care only about mine.
No.
I give it free. Yeah. Even if I'm hurt by 1 penny, I won't give it free.
Yes. Look the proportion 3. If B equal to 0, then profitable is this one.
No. What I'm saying to okay. We are talking about a different thing. What I'm trying to say that for the society, this thing will be profitable.
But it
won't
be tenable because we play
that's not. Yeah, that's not the Nash. That's not the Nash.
I understand that. That's why I'm trying to say. I understand that. What I'm trying to say now, you can actually go to the welfare because welfare is one of your important aspects. So you can actually now go to the welfare and you can say that. So there could be some welfare maximizing or social welfare improving licensing, but that is not coming. So that type of things. What I am saying that you can then actually make the selling of input. You can make the selling of input. Why it is important, you can make it more clear. That's what I'm saying.
No. So the licensor is not concerned about welfare maximization. Yeah. Licensor is concerned about its own profit.
No, licensor, but the social planner, because you are talking about all this pollution and all these things. So the social welfare is always a concern. So I am saying that
it is a consequence.
Exactly. So what I'm saying, you can have some policy implications from that side, and you can then make it clear that what is the implications of input cell and all these things. That's what I'm trying to say. So you can actually make more out of it. That's what I'm saying.
I understand.
Suppose it may be socially optimal, but it is possible that in that case, suppose that in that case the licensor may not license its technology, right? So if you simply
you can relate it to other thing like compulsory licensing. So you can relate it to other type of literature. That's what I'm trying to say.
Sorry,
you can get more out of it.
Hi guys, sorry for interrupting. It's very interesting, but it's about time for the next presentation. Let's give Arich some time to upload the slides.
Thank you very much, everyone.
Thank you very much.
Particularly that how free licensing can be maybe optimal. I should think of that. Thank you very much.